All right, so I was asked to see if I could go over question number 3 on the 2010 Calc BC test. The question you guys should have in front of you, or at least find it. But it says a particle is moving along a curve so that a position at a time t is x of t, y of t. So x of t and y of t is its position. Now, you guys should know x of t is its horizontal position and y of t is its vertical position. It says x of t is equal to t squared minus 4t plus 8. So I wrote that down for us right there. And y of t is not explicitly given. Both x and y are measured in meters and t is measured in seconds. And they say it is known that dy dt is equal to t e to the t minus 3 minus 1. So that's its vertical position. But that's the way it's moving. Okay. So the first part says find the speed of the particle at time t equal to 3. Now speed... we actually wrote this down a while back, but speed has a formula, okay? It's x prime of t squared plus y prime of t squared inside of a square root. That's speed, okay? So that means that this is a square root of x prime of t. So x prime of t would be 2t minus 4. So I'm going to put that right here. 2t minus 4 squared plus, and then y prime of t, well, that's dy dt. So it's t e to the t minus 3 minus 1 squared. So all of that stuff's basically given to us. So that's our speed value. Now, they want us to find the speed of the particle when t equals to 3. So what I'm going to do is just plug in a 3 into all this stuff here. And then you're going to use your calculator to basically do all the work. So 2 times 3 minus 4 squared plus, that's going to be 3 times e to the 3 minus 1 squared. And what you're going to end up getting, once you plug that into your calculator, is going to be about 2.828 meters. So when they ask you what is the speed of this thing, then this is how you're going to do it using that formula. So this is a formula that is given to us for speed. I don't know if you guys remember this, but we were doing this when we were going over magnitude. So good formula to know, okay, for speed of a parametric system. Okay, so that's part A. Now part B, before I get into part B, I want you guys to understand that speed is basically it's not the derivative of position, because the derivative of position is velocity, but speed is part of velocity, okay? Because velocity has speed and direction. So speed could be considered the derivative of position, okay? The reason why I tell you this is because they say find the total distance traveled by the particle from 0 to 4, okay? So for us, in order to find the total distance, let me write this down here. So our distance is equal to, now they want us to go from 0 to 4, so I'm going to integrate from 0 to 4. I'm going to integrate speed, okay? So I'm going to integrate speed because you would say the integral of velocity is position. Remember, speed is velocity, just it doesn't have direction. So I'm just going to integrate our speed function. So the integral from 0 to 4 of this equation. Now we wrote this equation down over here. Okay, so this is going to go right there. Okay, so I'll change this thing here. This is going to be 2t minus 4 quantity squared plus t times e to the t minus 3 minus 1 quantity squared, and that's going to be dt. Now again, you're going to let your calculator do this because question number 3 back in 2010 was calculator active. The first 3 were calculator, the last 3 were not. So you're going to put this into your calculator and you're going to get approximately 11.58, 587 or 588. It just kind of depends. I'm going to say maybe don't round it just to stay safe. So we'll kind of leave it like this. But you could put 11.588 and that would be okay as well. So that's part B when they ask us about distance. Remember, you integrate your speed to get distance. You're going to integrate velocity to get distance. And the reason why it's the same is because speed is velocity without direction. Okay, so that's okay to integrate speed or velocity to get distance. Now, part C. Part C says find the time t from 0 to 4 when the line tangent to the path of the particle is horizontal. Then they ask us, is the direction of the motion of the particle towards the left or towards the right? Now, since they're talking left and right motion, they're actually giving us a big clue, because left and right motion is not y value motion, that's x value motion. So I'm going to be dealing with x of t type of stuff. But they did mention that they first want us to find out when the particle is horizontal. So the way we find out if the line tangent to the particle is horizontal is by taking a derivative, right? So dy dx. Now, since we have parametric equations, that means that this is dy dt over dx dt. Now, we already know what dy dt is. Dy dt is t e to the t minus 3 minus 1 divided by, and then the derivative of x, we did that earlier. That's 2t minus 4. Okay, now in order for this thing to be horizontal, for this tangent line to be horizontal, we got to set it equal to 0. And the only thing that really matters is this. Okay, just the top part, because if the bottom part's equal to 0, that's not a horizontal tangent line, that's a vertical. Okay, we're looking for the horizontal, so we're just looking at that. So what you're going to do, yet again, is you're going to use your calculator, graph it, and use your 0 function to figure out where does it equal to 0, right? So use your calculator to figure out when that zeroes out. So we know, so let me just put t e to the t minus 3 minus 1 equals 0 when t is equal to 2.208. Okay, that's when that happens, at 2.208. So I guess that's one of the answers that they want, but then they ask us a second part to this question. They say, is it moving left or right? Well, x of t is position, so x prime of t gives us movement, right? So all I have to do, they say at that point, where is it going, left or right? So x prime of 2.208, well, that's 2 times 2.208 minus 4. Well, 2 times 2.208 is more than 4, and 4, whatever that's going to be, let's just pretend it's 4.5 minus 4. That number is going to be greater than 0. Since x prime of 2.208 is greater than 0, so let me write this down, 2.208 is greater than 0, then, well, positive direction in a horizontal motion would be to the right. So then the particle, or particle, not particles, the particle is moving to the right. So here we go. Here's your second answer to that problem. Okay, so that's how we find part C. Now, they did ask us to give a reason, so there you go. Since the derivative at that point is greater than 0, then the particle is moving to the right side. Now, part D says there is a point with x coordinate 5, so when x equals 5, through which the particle passes twice. Okay, find each of the following. Part 1 says the two values of t when this occurs. So they want to know, when is it that this stuff equals to 5 twice? Okay, In other words, when does x of t equal to 5? Now remember, x of t is t squared. I forgot what it was. So was it t squared minus 4t plus 8? And they're saying, when does that equal to 5? Well, let's move the 5 over because we want to set it equal to 0. So that's going to be a plus 3. So when I factor, that's t minus 1 and t minus 3. That's how I would factor. So that means it's going to happen at 1 and at 3. So there you go. First answer, we just found it. They said, when does that happen? There you go, when t equals 1 and when t equals 3. Now, the second part to part D says the slopes of the lines tangent to the particle's path at that point. So find the slopes of the lines tangent to the particle's point at that point. So I have to find dy dx. So, but for each point at 1 and at 3, so dy dx when t equals 1, and then I got to find dy dx when t equals 3. So that's dy dt over dx dt. Same for this one, dy dt over dx dt. Now for dy dt, when you plug in a 1, remember dy dt is t times e to the t minus 3 minus 1. So you're going to plug in a 1. So it's 1 times e to the 1 minus 3 minus 1 over the derivative of x was 2t minus 4. So 2 times 1 minus 4. So when you get that, you're going to get an answer of 0.432 once you actually calculate that. Do the same thing for the 3 value. So this is equal to 3 times e to the 3 minus 1 over 2 times 3 minus 4. Okay. So when t is equal to 3, so we end up getting a 1. Okay, so that's our answer for that one once you calculate it. Okay, so those are my two answers that they wanted. They wanted to figure out, sorry, I'm just putting that in there. They wanted us to figure out the slope of the lines tangent to the particle at path at that point. So another slope of the lines at that point. So that's dy dx. That's how we figure out slope. And we just plug in those two numbers. Now, last part. It says the y-coordinate of the point given that y of 2 is equal to this. So let me see. Given y of 2 is equal to 3 plus 1 over e. So they want to know, what is the y-coordinate at t equals to 2? Okay, what is the y-coordinate when t equals to 2? All right, this is my t value. So here we go. If they want me to find out my y value, okay, when t equals 2, then what I'm going to do is I have to get this information that they gave me, y of 2, and some other information that I may know. Now, I already know y of 1, and actually I already know y of 3 as well. Okay, so I know that information from before. So if I want to find my value for y of 1 or y of 3, okay, if I want to figure out that information, then I need to somehow use the fundamental theorem of calculus. Now, one thing I do know, I know that y of 1 has to equal to y of 3. Now, why do I know that? Because in the very beginning, they tell us, where is that? In part D, they say there is a point with x coordinate 5 through which the particle passes twice. And when we find those two values in part 1 and 3, right, that means that they're both equal to 5. So we know that we're going to get that value. But I got to try to figure out what is the y-coordinate of that point at 2. Okay, we do know that the x-coordinate is 5. We know the t value is 1 and 3. We want to know what's y of t. So this is how I'm going to do it. I'm going to use y of 2, and I'll use, let's say, y of 1. Okay, so the integral from 1 to 2 of d of y dt equals to y of, I said I'm going to use y of 2 and y of 1, so here we go. Okay, now if you're wondering, like, how is it that we're going to figure this stuff out, well, you guys have to remember, this is just the main fundamental theorem of calculus, right? If you're wondering, why did I pick dy dt here? Well, because I'm trying to figure out my position for y. Okay, I'm trying to figure out my position for y. So when I integrate dy dt with respect to t, that actually just cancels out, right? So it would be y of 2 minus y of 1. So that makes perfect sense. Okay, but instead of canceling this stuff out, let me just write out what I have here. So the integral from 1 to 2 of t times e to the t minus 3 minus 1 dt is equal to y of 2 minus y of 1. Now remember, y of 2 was given to us as 3 plus 1 over e. Okay, minus y of 1. So let me kind of keep this together. Now, what I'm going to do is I'm going to move, let me rewrite this, and then I'll do this movement here, because you're going to need your calculator here. I'm going to move this thing over to this side, and I'm going to move this thing over to this side. That way I can solve for y of 1. So y of 1 is equal to 3 plus 1 over e minus the integral from 1 to 2 of t e to the t minus 3 minus 1 dt. Now I have no idea what the integral from 1 to 2 of t e to the t minus 3 minus 1 is off the top of my head, but when you put that into your calculator, okay, have your calculator do the work, okay, make its value negative and then add 3 and add 1 over e. You should get your value for y of 1. And y of 1 should come out to 4. Now remember, y of 1 is the same as y of 3. So right here, it doesn't really matter which one you decide to do. You just find out that your y value happens to be 4. Okay, if you guys have any questions or any more questions on this, let me know. If not, keep working, guys. Keep working. Make sure you guys turn in your 2011s by Friday.